In this tutorial, we will be discussing Gay-Lussac's law, which relates temperature and pressure of gases. So as you know, the pressure of a gas is determined by how many times the gas particles hit a wall. The more times it hits the wall, the more pressure there is. Well, temperature is how much energy these gas particles have. So the more energy they have, the faster they're moving, the more times the wall is going to get hit. So therefore, as the temperature goes up, the pressure is going to go up because it's hitting the sides of the walls more often. One thing to consider here is that temperature has to be in kelvins. 100% of the time, make sure you convert that to kelvins. The pressure, not really that important as long as everything's in the same unit. So if one's in atmospheres, the other one has to be in atmospheres. If one's in millimeters of mercury, the other one has to be millimeters of mercury. However, with temperature, it always has to be in kelvins. So let's do a couple practice problems. A gas has a pressure at 2.0 atmospheres. So that word at links those two things together on that side of the equal sign, on the same side of the equal sign. 18 degrees Celsius. I see degrees Celsius here, so that automatically tells me that I need to switch this over to kelvins. So 18 plus 273 to switch it over to kelvins equals 291 kelvins. So V over T is equal to V over T. So 2.0 atmospheres over 291 Kelvin is equal to, what is the new pressure? So we're looking for the new pressure. So this should be P over T, not V over T. V would be Charles's law. All right. So what is the new pressure when the temperature is 62 degrees Celsius? So degrees Celsius, once again, I have to add 273 to make it into kelvins. That comes out to be 335 Kelvin. The easiest way to go about doing this is cross multiply and divide, just as if you were doing ratios. So 2.0 times 335, that comes out to be 670. We couldn't cross out any of the units yet, so atmospheres, kelvins, is equal to 291 Kelvin times X. Divide both sides by 291 Kelvin. And the kelvins cross out. So 670 divided by 291 comes out to be 2.30 atmospheres. We're left over with the atmosphere, so that's why I know what unit it is. Let's do one more. A gas pressure of 645 torr. Notice that we switched over to torr this time rather than atmospheres. As long as they're both in torr, that's okay. So we have 645 torr over at, that means these two go on the same side of the equal sign, 128 degrees Celsius. But I have to add 273 to it in order to make it Kelvin. And that comes out to be 401 Kelvin. So that 401 Kelvin goes on the bottom of this equation. What is the temperature? So I'm looking for this bottom number in degrees Celsius. That means we have to convert it back to degrees Celsius when we're all done. If the pressure increases to 824 torr. Alright, so we cross multiply because we're just doing ratios here. That comes out to be 330,424. The units are going to be torrs and kelvins. Is equal to X times 645 torr. Divide both sides by 645 torr. 645 torr cancel, and the torrs on this side cancel. So 330,424 divided by 645 come out to be 512 Kelvin. We're left over with Kelvin here. However, the question specifically asks for degrees Celsius. So that means we have to take it from kelvins to degrees Celsius. So we're going to subtract 273 to do that. And that comes out to be 239 degrees Celsius. And that is the Gay-Lussac's equation.